Measure on this one? Yeah, we wanted to use a laser tape measure, but the ones you get at Home Depot aren't real. They're not really using laser. They use laser for the aim, and then they use sonar for the distance. So you're like 2 inches at the most accurate. Right. Yeah. So a real laser rangefinder actually measures the shift or something to do with the way the light's reflected back.
It measures how long it takes for the light to bounce back.
It's like sonar.
So, except lasers are more accurate than sound.
So it was accurate to within a millimeter or less.
But with the water, it changes.
Yeah, when we would measure stuff underwater, the numbers didn't come out right until it dawned on us, and I don't know who came up with it first, but somebody said, it's the index of refraction of water. We're exactly 30% off, and the index of refraction of water is 30%. So every number we see, we need to adjust by 30%, and the number's right. So we decided we couldn't use that for distance because it only had a range of about 12 feet before it became inaccurate. So if we wanted to measure something over 12 feet, we couldn't do it.
It was mainly because of the clarity of the water.
Yeah.
You know.
Well, but how far? So how far did you need to be able to pull?
We didn't know for sure.
Because you didn't know how. Because
they
wouldn't the whole length of the pool.
Yeah. Well, not the whole length of the pool.
Plus, we couldn't see the little laser dot at the edge with the camera.
Yeah, in daylight.
Yeah.
So in daylight, the little laser thing probably wasn't that visible. But it did work for one thing, and that's what we did. Here, we put the laser rangefinder in a clear container, and we have a camera aimed right at it. And we aim the laser rangefinder to the bottom of the pool. So we needed to know your depth.
Got it.
So we would read the depth. We had to actually mount either the camera upside down or the thing upside down.
Yeah.
That's a good idea. Like you going in not knowing what the distance is going to be. You're like, you go, what if it's more than that? I go, we just got to pray that it doesn't. So you guys go up there not knowing. It's pretty cool.
But we knew in like the pool we were testing, anything beyond 12 feet we couldn't read. So if it was 13 feet long, we're like, well, we're screwed.
So, so that's why you
tape measure.
You use a regular tape measure.
Just a regular tape measure.
Looped it on, pull back.
Oh, a metric tape measure.
Metric tape measure.
Because all the measurements had to be a metric.
How hard is it to find a metric tape measure?
Harder than you think.
Yeah.
Try to go find one.
Yeah,
You gotta look.
We found a lot that had both of them, but we couldn't read the little numbers for the metric one.
Yeah.
So you had to get one that fit just the. Got it.
And then to see what the distance was, it was just the camera read the tape measure.
So this camera is entirely there to get the metric reading. This one is entirely there to watch the process of sucking up the fluid.
Yeah.
That camera is so you would have your depth, and this is the only camera that you use for direction.
Driving.
Then we had our battery in here because we wanted the most massive part of the robot at the bottom, and the bigger air compartment on top, so that we keep our robot upright.
More buoyant, right?
And then
so all the other teams had literally cords going from this to like
every motor had a set of wires going to the surface.
And because they're relatively high current motors, you had to have a pretty big gauge wire, 100 feet of that. You know, so you have a voltage drop, you have all that. But by the time you take, what do we have, four motors here? If that's for your motor, and you've got 4 of them, okay, now you have a video cable, and they'd use video cable. You know, by the time you're finished, you've got a cable like this.
Right.
If you can
it's not
tie, yeah, so tie a 100-foot cable like that on your belt and go swimming around in the water. I mean, it's like
they're dragging the cable on the bottom of the floor, so now they even have to be strong enough to drag the cable.
Yeah.
But it's too heavy. The
So you need more power.
Yeah.
So the following year, everyone's used your method.
A lot of people switched to onboard batteries.
Which now in made is illegal.
Or they made it. For the years we did it, they penalized us. They said if you use it, you can only use 12 volts and you can only have 20 amps.
Why?
And other teams were allowed to use, I'll tell you why. Other teams were allowed to use 48 volts and 60 amps.
Right, which is
so like, well, that's not fair. You want us to use 1/8 the power because we were smarter? And they said, well, that's a safety issue. I go, what safety issue? Which would you rather be shocked with, 12 volts or 48 volts?
Which neither.
So that wasn't it.
Is anyone in the pool when this is happening?
No, but if you have a crack in the wire and you're holding it, you could get shocked.
Right.
But you should be wearing rubber gloves. Your system should have some kind of ground fault somewhere.
Right.
So if there's a short circuit, it should pop.
Right.
But you never know. Something can go wrong.
Yeah.
And the 3rd year we did it, we had a fiber optic cable. We had a beam of light